Hello everybody and welcome to the first video in the series of GitHub Foundation Certification Prep. So we have this video, we will be going through the first section of the first domain of the certification, which is Introduction to Git and GitHub, and specifically Git and GitHub Basics. So we'll be going through what is version control, what is distributed version control, then we will be describing the basics of Git and GitHub, then explaining the difference between the two, then describing what a GitHub repository is, and then what is a commit, a branch, a remote, and then we will be describing the GitHub Flow. And that's it for the first section. So let's get started on it. Version control or software configuration management tools are programs that allow you to track the state of your project throughout time. This means that you can imagine it as some kind of time machine where you can travel back in time into some specific point in the past and see how your project and its files looked at that point of time. This is super useful because if you find out that your application has some kind of issue or bug, you can track down specifically which set of changes has caused this issue, and that helps tremendously with debugging. You can probably know that other things like Word or Excel and other programs in your computer also have this kind of capability of seeing the history of files, but version control tools go much beyond that, and it offers a lot of additional features and tools which I will be explaining later throughout this video. There are two major types of version control systems. The first one is centralized, where when multiple people work on the same project, the project is hosted somewhere on a server, and each person then has just a working copy of what they are currently working on their local machine. So in case the server goes down, the person is not able to go back in history and see how the project looked before, because they don't have the full history locally stored. In comparison, distributed version control means that every single person who is working on the project has full local copy of the project with the whole history of all the files that are there. That means that they are able, even if the server went down or if the server was destroyed, every single person would still have the full history on their local machine, so it's very easy to recover. And it also means that if they are offline, they can still work completely, and they can even go back in time and see how the project looked before, and they can do everything without any connection to the network needed. This brings us finally to Git, which is a distributed version control system which was developed originally by Linus Torvalds to improve the collaboration on the Linux kernel development. Git is very efficient as it allows you to very quickly switch between different views on your project. So you can quickly jump back in time into the history or jump between different branches of development on your project. It also is very lightweight as it stores just the differences between different versions of your project's files. And for these reasons, especially, it became the leading and the most used distributed version control system there is. It's actually used by over 95% of software development projects in the world. So it's safe to say it's here to stay, and it's the most common way on how to track software development projects. Now we get to GitHub, which is a AI-powered cloud-based hosting service which allows developers to host their Git repositories on the cloud and then collaborate with them either with their coworkers inside of an organization or with the public as an open source project. It's very important to distinguish between Git and GitHub. Git itself is just a command line tool that you can use to track the state of your project and save snapshots of it throughout time. In comparison, GitHub is a full developer platform that builds on top of Git. So it uses Git as one of its core tools, but it adds a lot of features on top of it. So instead of just getting a Git repository hosting, you get also ability to track issues and feature requests on your project. You also get access to project management tools. You get access to CI and CD pipelines. You get access to pull requests and code reviews. And you also get a set of AI tools that you can use, for example, Git Copilot. In addition, GitHub also offers account management, team management, organizational management, and also many security-related tools that allow you to avoid sharing sensitive data with the public and so on. So GitHub is a full developer platform, whereas Git is just a command line tool that GitHub is using. So now let's get the basic Git terminology in place. A repository in Git is the most fundamental unit that contains, it's a container that contains all of your project and all of its files, as well as the history of the files, and also tracks the changes to individual files. On your local machine, a repository will be represented as a single directory, which contains another directory, which is called .git, and that one contains all the necessary infrastructure for Git to work. The second most fundamental unit of Git is a commit. When you make changes to your files, you can then decide which one you want to keep by staging those changes and kind of preparing them to commit them into Git. The commit consists of a user-friendly message that explains the changes that you made since the last commit. And then when you commit the changes into Git, it generates a unique ID that kind of represents this snapshot of your project in time. So then later in the future, you can always go back to this specific commit and see how your files looked at that point of time. Development of a project happens on branches. A branch is kind of a named pointer to a commit. And when you add new commit to a branch, the pointer moves to that new commit and its ID. Usually a project has a main branch, which is called either main or master, and the stable development of the project happens on this branch. But when multiple people collaborate on the same project, they can also branch out. So take a specific commit and start building on that commit some specific new feature. And that happens on a separate branch, which is usually called a feature branch. And when they are satisfied with those changes that they did, they can merge those changes into the main branch. And that happens through a thing that's called a merge commit, where they take all the changes that they made and add them as a single commit to the main branch, which kind of unifies the main branch with their changes. Sometimes it happens that there are some conflicts where two people were editing the same file simultaneously on two branches, and at that point of time you need to resolve the conflicts by taking either the version that's on the feature branch or on the main branch into consideration and resolve those conflicts between the two changes to kind of create the final version that will be there on the main branch. So that was a lot of theory, so now let's see it in action as I will show you a demo of the most basic Git commands. First off, to use Git, you have to install it, and you can do that from the git-scm.com URL, where you can download it for any OS that you can imagine. I'm using Windows here, so I've already installed Git on my machine, and I have prepared an empty directory where I will be demonstrating Git repository. So this test repository folder is now empty, and I will now initialize Git in that folder. So I can write git init, which is a command that initializes Git in a given repository. And when I press enter, this generates the .git folder, which is a folder that will contain all the infrastructure necessary for Git to work. You never should touch these files, because doing so would break your Git repository, and that would be a big problem. So This folder usually is hidden, but I have displayed hidden folders, so it's showing up here, is where all the magic of Git happens. Now, the Git repository, I can show it to you in a visual way as well, where I open it here. It contains nothing right now. But what I can do is I can create a new, you can see that I'm on the main branch. This is the main branch of the repository, the main branch where the stable development of the project will happen. And what I can do now is I can call git status, which says there are no commits yet, and there's nothing to commit because I haven't added any files so far. So I will add one new file, first file, and I will say hello in that file, save it, and now that file is not yet part of the repository because it's not being tracked by Git. If I say git status, it noticed that there is a untracked file which contains some new changes. So what I can do is use git add, which adds a given file to Git tracking, which kind of stages that file to be committed. So if I say git add first file txt, it will add that file. Or in general, if I want to add multiple files, I can do git add dot, which will add the files in the folder all at once. So now if I do git status, it says there are changes that can be committed. So there is a new file called first file txt. So now with that new file, what I can do is I can commit it. So I can do git commit, provide a message with the -m command, and I can do first file, for example. This is a user-friendly description of the changes that happened in that specific commit. So if I do enter, this file is now committed, and it created a commit on the main branch. So you can see that we are on the main branch, nothing is there to commit, but if I look in the visual representation of Git, and I definitely recommend you to use one of these visual tools, as they make all these things much easier when you want to when you work with Git. Instead of using just the command line, these visual programs will make it much easier to visualize what's happening in Git. So I'm using Git fork, which is a friendly Git client, which is available for Windows and also for Mac, so you can download it and use it. I definitely love it, and it's made by two very friendly people, and yeah, it's definitely a very cool thing. So anyway, I digressed a little bit. So now let's go back here. With the change committed, we have made the first commit in our main branch, but we can now do further changes. So if I decide I want to say, instead of hello, just hello world, and save the file, now Git will tell me that I modified the file. And if I want to, I can now add the changes again to staging. So now the file, the changes are staged, so they are ready to be committed. And now I can commit my change again. So commit new change to first file. When I press enter, this created a new commit in Git, and you can see it represented here as a new dot on this line. And the cool thing is that I can now go back in time to the previous version as well. To go back in time, I need to know the hash, the unique ID of the commit that I made. To do that, I can use the git log command, which will give me the list of recent commands in my repository, and the commit ID is always displayed here. And I want to check out this older version of the first file, so I can copy this commit hash and now do git checkout and provide the hash. This will travel back in time to that commit hash that I specified. So now we are no longer on the main branch. We are in detached head state. So that means that we are not on a no branch. We are actually on just the specific commit. And you can confirm that we've traveled back in time by opening the file where now it says hello, not hello world anymore. So this is very nice because now I can see how the project looked before I committed the second change. And what I can do now is that I can decide to actually create a new feature on that specific point of time. So if I want to create a second file at this point of time. So what I will do, I will create a second branch on which I will develop it. So I will use the command Git Branch, which I will call feature new second file. And now I will check out this branch, second file. The branch is created at the specific commit that we are currently on. So as if we can visualize it, we are currently on this first commit, and the branch is also at this point of time. So if I do git checkout feature second file, it will set this branch as the active branch. So you can see it's now displayed in bold because we are on this branch specifically. And now I can do any changes I want. So I can add second file, and save it. And now if I do git status, I can see my new file is there. So I can do git add dot, which will add it to staged files. And now I can do git commit second file. When I press enter, this will create a new commit that is separate from the main branch of development. And you can see it here. The main branch of development is showing here, but the second file is now in a secondary branch displayed here. And what I would like to do now is to merge that new change, that new feature to the main branch. To do that, I can first jump to the main branch. So check out main. This will bring me to the main branch. And as we switch there, you can see the second file disappear because it's not there. It's only in the feature branch, in the specific separate development branch of my project. It's not here. And I can do git merge when I specify the branch that I want to merge. So now I want to merge my changes from the secondary branch into the main branch. And to do that, I say merge and the name of the branch that I want to merge into the current branch. So if I do this, the changes from the secondary branch are now brought into my main branch, and they are both part of the main branch now. So it created this additional commit called merge commit, which kind of joined the two development branches into one. And you can see that both files are now there. One is containing the second file, and the second is containing the latest version of the first file. So it says hello world. And this way, multiple people can work on the same project, change files as they need to, and then merge their changes together and create new stable version of the project, which is very cool and very useful. What we have seen so far was just working on a local repository in Git. But when you want multiple people to collaborate, you need a shared location, which is either on the cloud or on a network share, where the Git is hosted and where the people collaborating on the project can push their changes. And exactly for this purpose is a remote. A remote in Git is a pointer to some external hosted version of the same repository. And you can then take your local commits or branches and push them into that remote repository by using the command git push, which then pushes the changes to the cloud or to the network share so that other developers have access to them. A GitHub repository is exactly what I explained. It's a remote and cloud-hosted version of your Git project. However, GitHub repository also adds additional features, as I mentioned before. So a GitHub repository also contains links to issues, project management, pull requests, and security, and also GitHub Actions, which allows you to automate builds and so on. So GitHub repository is a kind of supercharged version of a Git repository with a lot of things on top of it. Let's now jump into second demo where we will create a new GitHub repository and try to work with it. I'm now on my personal GitHub profile and I will create a new repository. So I will call this repository GitHub Foundations 1 and I will make it public so that anyone on the internet can access it and potentially see its contents. Usually you can also provide some useful description and also README file where you explain what the repository is all about. I will keep it for now empty. You can add git ignore that allows you to ignore some specific files or specific file patterns in your repository and not include them in your GitHub repo. And then you can also provide a license where you can pick one of the open source licenses that are there available. So what I will do, I will just skip these for now and I will create a repository. Now this repository is completely empty, but if I grab its URL, or I can also click here and do follow these commands that are provided here, I can, for example, clone this repository. I can clone this repository locally. So I can open my terminal and in an empty folder, and I can do git clone and provide the URL. This will clone this Git repository from GitHub to my local file system. And now in this folder, I should have the copy of that folder there. So I will new folder. There's a folder where I put it, and it created this folder GitHub Foundations 1, which is matches the name of the GitHub repository. And now it contains just the Git folder again, very simply, and nothing too special there. So let me just open that repository as well. So I will take that folder and open that repository in my fork, so you can see it's empty now. And I can now make some changes. So I can add a new file called hello. This is now an empty file, but it should show up here in git status. So sorry, I need to go to that GitHub Foundations folder now first. So git status, which will git status will show me that the file is new. I can do git add dot, which will add it to stage files, and then commit called first file. So now, all right, I wrote it incorrectly. So commit first file, and you can see that now the file is there. Nothing to commit. There is a new commit in my main branch, but this change is now only local, and I don't have it in GitHub itself. So there is nothing here. If I refresh, there is nothing there. But what I can do, I can now push my change, or kind of upload my change to GitHub. So I can do that by doing git push, which will take my local copy and upload it to the GitHub servers. So now if I refresh on GitHub, you should see that the file is now there. So this file is now available on GitHub. But pushing to the main branch is not something that you usually do. It's something that is discouraged usually. Instead, it's better to work with feature branches and then allow then create a pull request, which is something that allows other maintainers of the project to see your changes and then approve them or provide some additional comments to change that file. So what I can do is I can create a new branch here. So I can do git checkout, git branch feature second file. Press enter. I can then check out feature second file. And now I can create a second file there. I can add it and then commit. And now I can git push, which will push my changes to the remote repository. But as you see, it failed with an error because this branch, this feature second file, does not exist on GitHub yet. So I need to kind of create it by using this command: set upstream origin, which is the name of the remote repository. By default it's origin, but you can name it different as well, so you can have multiple different remotes as well. And then the name of the branch will be feature second file. So I will use that command, and this will create the branch and push it to GitHub. And now the branch is there. So there's not only just main branch, but also the secondary branch. And I can create a pull request, which will show that there is some change that wants to be merged into the main branch, and people who could then see what the changes are and then decide if they want to include those changes in the main branch or not. And if yes, they can use merge pull request button, which will then create a merge commit, as we saw on local file system, but now it's happening on the side of GitHub. So if I confirm merge, this change was now merged into the main branch, and both files are now there. In addition, the feature branch, the secondary branch, was automatically deleted. So now you can see there is no second branch there because there is just main, and the previous one, the merged one, was deleted. So it was deleted automatically for us. So that's a very basic way of how you can work with GitHub and how you can upload your changes to this hosted environment. And I will explain this in more detail later in further videos, but I think this should be enough for the basic understanding. And the approach that we just took is actually called GitHub Flow, where you first, when you work on the project and want to create a new feature or add some new bug fix, you create a new branch, make some changes on that branch that's yours locally, then you push it and create a pull request that anyone else from the project can review. When they provide some review comments and something is not up to their liking, you can then address those review comments. And when everything is okay, your pull request or your branch is merged into the main line of the development, and your feature branch is then deleted. And this whole process is called GitHub Flow, and it's the recommended approach that GitHub provides as the ideal way of how to collaborate with other people on a single project in GitHub. So if you're asked what GitHub Flow consists of, it's these 6 steps that together make up a collaboration or contribution to an open source project. And just like that, we went through the first section of GitHub Foundation certification prep. We've seen version control and its types. We compared Git and GitHub. Then we went through the basic Git terminology and seen that in action on a local repository. Then we explained what a remote is and how you can create a GitHub repository, to which we finally pushed some changes from our local environment. And we explained what GitHub Flow process means and how you can utilize it to develop new features on your project. So I hope this was a useful session. Please subscribe to my channel if you want to get notified about future videos in this series or other videos that I will be publishing. And in the meantime, keep coding, have a great day, and I will see you later.